Hello everyone. If you are a newcomer for this channel, please subscribe, like and also comment. If you like the video, share for other friends. This is Lata Gutta official page. Today I'm gonna present on the topic of database management system architectures, and also a data independence. We will see one by one what is database management system architecture and also what is data independency. Let we see. The first concept about database management system architectures and data independence is a major aim of a database system. The main aim of a database system is to improve or to provide a user with abstract view of a data, to make a user to view some abstract view of the data. That means if you have a lot of data, which we store in a database, rather than view all the data stored in a database, you will view some important table, some important row of the table, and also some abstract of the data which we store in a database. That means we hiding certain details of how data is stored and how data is manipulated in a database system. This is the main aim of a database system. That means providing a user with abstract view. That abstract means rather than viewing the whole data, only viewing few parts of the data, and also hiding certain details of the data stored and also how the data is manipulated. This is the main aim of a database system. The other one is since the database is shared resource, each user may require different view of a data held in a database. Since the database is, as we know, database is a shared resource, so each individual user or each application needs or require different view of the data held in a database. This is another concept. Accordingly, there are several types of architecture of database system. According to database management system, we have three level architecture of database management system. The first architecture of the database management system is the internal level or the physical one. The second one is the conceptual level or the designing model. The third one is the external one. The external one or the view part of the database system. But the other one is, in this architecture, schema can be defined as three level. That is why we say three level of schema. That's the reason why we say three level of schema. The goal of three-schema architecture is to separate user application and the physical database. One of the main goals of three-schema is to separating the application level or the view level from the physical database or the place where the data is stored, to separating the place where the data is stored and also the place where we put the data for permanently. Then from the stored data, we can retrieve the data by using this application level. So the main goal is to separating application and the physical level. The first level is about internal level. What is internal level? An internal schema which describes the physical storage structure of a database. One of the main goals of this internal level is to describe what? The physical storage structure. And also the internal schema uses the physical data modeling and describing complete details of storage and access part of the database. That means this internal level is more concerned on the physical storage structure of a database. The second one is to describe the detail of data storage. The third one is to identifying or to specify or to describe the access path of the database. So the main aim of this internal level, the functionality of this internal level is, the first one is to describe the physical storage structure of the database. The second one is to identify or to describe the access path of the database. The other one is to describe the detailed storage structure. The detailed storage structure, that means describe complete detail of the data store and access path. Describe the storage structure of a database. So this is all about the internal level. The way database management system in the OS perceives the data is also other description of internal level. The internal level is concerned with such things, that means the storage space allocation. Whenever you store the data, it allocating the data. So spacing allocation is the functionality of internal level. The second one is record description of storage. Whenever you storing the data in a database, they give us some description about the data, what you are going to store, and also record placement. To give some placement for your record is the functionality of the internal level. The second one is the conceptual level. As you know, this conceptual level is, we can say, conceptual schema. That means which describes the structure of the whole database, for the community of the user. That means conceptual schema hides the detail of the physical storage and concentrate on describing the entity, data type, relationship, user operation, constraints, security, integrity, information. As we see in previous, in internal level is mostly concerning on what? The physical structure of the database. But the conceptual one is not focusing on the detailed description of the physical storage. Rather, this conceptual level is focused on the entity you used, the data type, the relationship between entity, the user operation. That means maybe adding, drop, delete, maybe different kinds of operations are there. So that operation, the constraint or the role the user must fulfill to use the data. The fourth one is about security and integrity information. So this conceptual level is only concerns rather than description of the detail. It only focuses on the what data we store, which data type we may use, what kinds of relationship between entity, what kinds of user operations are there, what constraint to fulfill to use the database, what kinds of security may be implemented, what kinds of integrity informations are there. So from this definition, we understand this conceptual schema is a more focus on the conceptual view. There is no implementation in conceptual level, only what? Concept. What it is from the definition, conceptual level is more focused on the concept. Which concept? That means we can logically identify the entity, we can logically identify the data type, we can logically identify the relationship between entities. That is the description. For structural database, which it hides the detail of the physical storage structure, concerned on describing entity, data types, and relationship is about the conceptual level. The third one is the external level. External level, it includes a number of external schemas or user view. This external level is, we can say it is a user view. This describes the part of the database that the user is interested in. That means it describes the part of the database. It describes the part of the database that a user is interested in, and hide the rest of the database from the user or user groups. It means that by using external level, user can view some abstract of the database, rather than view the whole database. So this external schema is a part of application program. It is a part of application program which hide the details of the data stored in the database and view some interested part where the user wants to view from the database. Show only that things. So the user view of the database, the way user to perceive the data, describe part of the database that is relevant to each user. Each user has a view of the real world in different ways. For example, date may be viewed in day, month, year, month, day. So by this means, user can view the data stored in the database. There is two options, maybe day, the first column, month, second, year, third. But in case of the second option, reverse year, month, day. So we are different options to view the data stored in a database. Entity attribute relationships that are not of interest may be still represented in database, but the user will be unaware of them. That means if you have a lot of data, users are not unaware of the many data stored in a database, rather than he or she only focus on the thing which we perceive, from the database. If someone creating day, months, year, he only view day, months, years, but there's a lot of data stored regarding to day, months, years. That is the reason. This is the database architecture of SPARE. This is the logical one, is from conceptual, above conceptual, logical or conceptual database. Below the conceptual is, we can say, the physical designing. This is the abstract. With mostly I use the word abstract. When you say abstract, we have this table. Table have student name, ID, age, gender, entrance, year, grade. This is the whole table we store in a database. But user may view only ID and the grade from this table. That means we have grade here, and also we have ID. So this ID and the grade is called, what we call it, the abstract of this table. The abstract of this table, because it is a subset of this table, but user only want to view this part. That is the reason why we say, what is data independency? When we say data independency, the schema architecture can be used to explain the concept of data independency. It is defined as a capacity to change the schema one level of a database system without having to change the schema in next level. Whenever we change the internal level, whenever we change or we may modify the internal level, that means not affecting the conceptual levels. During we modify some internal level, if there is no effect on the second level, that is what we call is data independence. In case of data independence, we have physical data independence and the logical data independence. So logical data independence is a capacity to change the conceptual schema without having to change the external schema. Whenever we change the conceptual schema, or conceptual schema, if there is no change on the external schema or the application, that is what we call is logical data independency. That means we may change the conceptual schema to expand the database, adding a record whenever you add some kinds of records into the table, or to reduce the data stored in a database. That means removing the records. Only the view definition or mapping need to be changed in database management system that support the logical data independency. This is what we call is logical data independency. So we can say that logical data independence is whenever the user changes the conceptual schema, by adding some records or by removing some records that may not affecting the external or the application schema. Is what we call is the logical data independency. The second one is the physical data independency. That means is the capacity to change the internal schema without having to change the conceptual or external schema. Since physical data is the lower part, whenever you change the physical schema, that may not affecting the conceptual, that may not affecting the external schema, is what we call is the physical data independency. Change to the internal schema may be needed because some physical files had to be reorganized. For example, if you want to reorganizing some data which is stored in a database, in a physical or in physical memory, whenever you change that things, that may not affecting the conceptual schema, that may not affecting the external schema. If it fulfills this criteria, we can say that the physical data independence is fulfilled. Neither the application nor the external or conceptual schema must be changed when changes are made to data storage specification. Whenever there is some kinds of modification in a storage specification on physical one, neither the application nor the external or conceptual must not change it. So database management system is the interface between the conceptual and the physical data model. We can say that physical database management system provide interface between the conceptual and the physical database. Thank you very much. We will meet in the next video. Thank you.